So today in this video we will find the magnification that is produced by a simple microscope or by a single lens, or what we call it as a magnifying glass, right? So here first of all I will define what magnification is. So magnification is basically how enlarged an object can be seen through our eyes with the help of the lenses, right? This is called magnification. Now the simple definition of magnification is, let's say magnification is defined as m equal to, there are multiple definitions, I will write all of them. So magnification is image height upon object height, or let's say we can say image distance upon object distance. Also it is the angle subtended by the image, that is beta, upon angle subtended by the object, that is alpha. Now where is beta and alpha? See, here is beta. So beta is the angle subtended by the image. So this is image, that is the enlarged image that is observed of object A and B. So A and B is the object, A and B is of the object, and A dash B dash is the image. So the angle subtended by the image at the center, at the principal, at the pole is alpha, is beta, right? So beta is the angle subtended by the image, and alpha is the angle subtended by the object, right? It is the, I see I have extended this horizontal line towards point A1 so that I can find the angle subtended by the object on the center, or what is the value of alpha when I extend AB to left hand side to find the actual angle that is subtended by the object, right? Okay, right. So how we can find the magnification? So see, clearly we can see that magnification is beta upon alpha, right? Magnification m equal to beta upon alpha. So what we need to do is we need to find beta and alpha. Now how we can find beta and alpha? For this we have to approximate, right? See, in optics all the angles are small angles, right? Small angle approximation will take small angle approximation. Now when we consider the small angle approximation in optics, then we can clearly assume that tan beta is nearly equal to beta and tan alpha is nearly equal to alpha, which is in case true for small angles, right? So first what we'll do, we will first find tan beta. Now you have to remember this formula: sine, cos, tan, h. See, tan is perpendicular upon base, Now to find tan beta, I have to consider this bigger triangle, that is A dash, B dash, C, this triangle that I have outlined. I have to consider that triangle. Now what we have to find in tan beta, we'll consider triangle A dash, B dash and C. So tan beta is perpendicular upon base, so this is perpendicular A dash B, A dash perpendicular upon base. What is base? Base is B dash C, right? So second one. Now for tan alpha, we'll consider this triangle, this one, right? This triangle. So in this triangle we have perpendicular. What is perpendicular? Perpendicular is A1 B dash upon B dash C. Now from equation 1 and 2 we will substitute equation 1 and 2 is this in this equation, right? So we'll get m is equals to tan beta upon tan alpha. So tan beta is A dash B upon B dash C, and tan alpha is A1 B dash upon B dash C. Then we'll get A dash B upon B dash C multiplied by B dash C upon A1 B dash. So these two will cancel out. So we'll get A dash B upon A1 B dash, A dash B upon A1 B dash. So this is the final equation that we'll get with the help of the this definition, this equation 1 and equation number 2. So this is clearly the image height and this is the object height, right? Now what else we can do here is, what else we can do, so also we can write it as, magnification can also be written as m is equals to image distance upon object distance, which is v upon u. Now here v is the distance at which the image is formed. The v is the distance between the image and c is clearly mentioned to be d. So we'll write here d upon u. U is just u, and both are negative because they are on the left hand side of the pole. So negative will obviously get positive, right? So m is d by u or v upon u. Now further what we can do is from Lenz's equation. Now Lenz equation is 1 upon v minus 1 upon u is equals to 1 upon f. Now if we try to simplify this, right, if we try to simplify this, what we can do is here we can multiply the whole equation by v. We can multiply the whole equation by v. So I will get 1 minus v by u is equals to v by f, is equals to v by f. Now I can substitute it 1 minus m equal to v upon f. So magnification m becomes, or what we can do is you can write multiplied by u. If you multiply it by u, then u equal to d. So we can do that way also. Let me do that way. So multiply it is by equation, not by v but by, let me just rub it and then I will do it. So what we can do is I can multiply it by u, let's say. So it will get u by v minus 1 is equals to u by f. Now how can we further do it? You can simplify it this way also, and the way which I have told you in the previous steps, right? So this is how we can derive the magnification of a simple microscope. So this is Lenz's equation, this is magnification v by u, and if we want to derive it in this way, so what we can do is, see, we can, again I have to go back and again I have to tell you, right? So this is the Lenz's equation, this one, and this is the equation for the magnification. So they look at these two equations. I will again substitute here is, I will multiply this equation by v again. So I will get 1 minus v by u is equals to v by f. So this equation, this one, becomes 1 minus d by u, right? It becomes d by u, that is equals to v by f. So this is how we can simplify the equation, right? So this is the equation of magnification. So this is how a magnification of the simple microscope can be obtained. Thanks for watching.